Hello and welcome to the Strygate College Further Maths video on successive transformations using matrices. Just like at GCSE, where you could have a reflection followed by a rotation or a translation followed by an enlargement, you can combine two transformations together. And we can do that using matrices. The only thing that you need to just be a little bit careful about is the order that things happen. So you need to use a combination of your knowledge of transformations, your knowledge of the matrices, and some diagrams using the unit vectors. So it says here, find the matrix representing the combined transformation, an enlargement scale factor 3, center naught, followed by a rotation through 90 degrees. So first of all, think what your two matrices are going to be. Your enlargement matrix is going to be 3, 0, 0, 3. You should just be able to write that one down. A rotation of 90 degrees. Let's just check whether it's clockwise or anti-clockwise. This is actually clockwise. So just have a quick think. If I was just doing this quickly, I'd say to myself, where does the unit vector 1, 0 end up? It ends up at 0, minus 1. Where does 0, 1 end up? Well, that ends up at 1, 0. So that's my rotation matrix. Now, which one happens first for these for this combination? It says the enlargement followed by. So if we're going to do the enlargement first, imagine you've got a point here and you're multiplying it by that. You would do 3, 0, 0, 3 multiplied by the point. And then after that, you would do the rotation. So that's the order you would multiply by. So that's the order we multiply the matrices by to find the combination matrix. So if we do this, we're going to get 0, 0, 0 plus 3, 0, and 0, 0. So that is the matrix that represents those combined transformations. So you just need to watch the order that you do the transformations in. The transformation you do first comes on the right, because that would be if I was multiplying by a particular point. I'd put the point here, I'd do that multiplication, then I would do that one. Okay, question 2 involves when you're given the combination matrix and you've got to work back to what the some details of the transformation. So we're told this matrix represents a combination of an enlargement and a reflection. Find the scale factor of the enlargement. Now, if you remember the determinant of the matrix, so the determinant of this gives the scale factor. So the determinant of 0 minus 4 minus 4, 0, which is equal to 0, take away 16, so that's minus 16, tells me the area of the scale factor. There's the area scale factor. The minus means there's a reflection. So really we should be looking at the modulus of this. So the modulus of minus 16 is 16, obviously. So the area scale factor is 16. So the linear scale factor is 4. So you just need to remember that point there. Now that means that we've got a matrix for a reflection followed by an enlargement scale factor 4 and when we multiply those together, they're going to give us this matrix here. So we need to know what this matrix here is going to be. We can work it out in a variety of different ways. We could say, so when we multiply these together, we're going to get 0 minus 4 minus 4, 0. So what matrix goes here? So we could work this out by saying, right, well, whatever I've got here multiplied by 4 plus nothing has got to give me nothing. So I can tell that that number there needs to be 0. When I multiply here, I'm going to have nothing times nothing, and then something times 4 has got to give me minus 4, so that's going to be minus 1. Something times 4 plus something times nothing has got to give me nothing. So this here has got to be, let's just do that one, it's got to give me minus 4, sorry, so that's got to be minus 1, and this last entry has to be 0. And that represents, if you think about where the unit vectors end up, so that's where 1, 0 starts, so it maps to 0, minus 1, so that's going to go down to there, and then the j vector here maps to minus 1, 0, so this is a reflection in the line, so that's mapped to there, so that's a reflection in the line y equals minus x. So it says the equation of the mirror line y equals minus x. We could also have done this by considering where do the original points end up under this mapping. So we could say 0, 1 maps to 0, minus 4, and 1, 0 maps to 0, minus 4, and 0, 1 maps to minus 4, 0. So we can work that way round. Notice if you're given a question where you're told there's a rotation involved, it's a very good idea to use the rotation matrix that you're given of cos theta minus sine theta, cos theta to work that out. Those are the slightly tricky questions, so you just need to use the matrix that you're given in the formula book to help with those questions.